Welcome back to Coolant U, the 10-part video series that helps you reach a higher degree of knowledge about engine coolant. Made possible by Recochem, your partner in formulating solutions. In Module 5, our focus is on the differences between light-duty and heavy-duty engine coolants. We'll explore the varying demands of each, cooling needs, how corrosion inhibitor packages differ, and global use versus nameplate-specific application formulations. The heavy-duty diesel engine, often made from cast iron and designed to produce enough torque to tow, haul, and run continuously around the clock, whether they're in fixed equipment on site or in a vehicle out on the road. An HD engine like this routinely travels more than 250,000 kilometers per year. And this is a modern light-duty engine, often made from aluminum. It's designed to provide fuel economy and produce enough horsepower for a convenient and safe driving experience for a daily commute, errands, and an occasional family vacation or road trip. These are two very different engines built for two very different applications. Let's compare. Heavy-duty engines travel 10 times the range, are loaded above 70% capacity, contain a larger volume of coolant, use replaceable wet sleeve cylinder liners, and operate in more severe conditions. But the biggest difference is what happens when heavy-duty equipment fails. Downtime for an HD engine is more than an inconvenience. Serious financial impact and safety hazards can make it a high-stakes concern. In response to fuel efficiency standards, both light and heavy-duty vehicle manufacturers are designing new engines that produce greater power outputs from smaller, lighter engine blocks. These smaller, high-performance engines generate a lot of heat. As a result, light-duty engine coolants play a greater role than ever before. More heat to remove, more components to protect, and smaller cooling systems that help reduce vehicle weight and size. HD engines put even greater demands on their cooling systems. Larger water pumps and radiators, as well as ancillary equipment like intercoolers, help mechanically assist in protecting an HD engine block. However, the coolant formulations themselves provide the most protection. And as we've already discussed, the biggest differences are the type of corrosion inhibitor package used in the coolant. Conventional coolants are suitable for older HD engine blocks, which are primarily made from cast iron with copper or brass radiators. However, these formulations contain inorganic inhibitors like nitrate, molybdate, and silicate, which eventually deplete. As this happens, they must be replaced by a dose of supplemental coolant additives. To address this, some engines have a chemical filter that screws directly onto the engine block, filtering contaminants and adding supplemental corrosion inhibitors for improved performance and extended coolant service life. Nowadays, newer nitrate-free coolant formulations are designed for modern aluminum-based HD engines. Nitrates not only degrade faster in hotter-running engines, they can react with the flux used to braze aluminum parts together, altering the coolant's pH, increasing corrosion, and resulting in solids that clog filters, coat heat exchangers, and cause a buildup of scale on cylinder liners. Removing nitrates from coolant formulas prevents these problems. But new coolant formulations go a step further, replacing the conventional corrosion inhibitors with OATs. Organic inhibitors don't react or deplete. They remain intact and therefore don't require use of additional products like SCAs, boosters, or extender additives. As a result, OAT coolants can be more cost-effective than conventional formulations when measured over the entire service life of a vehicle, even though they cost a bit more. For light-duty vehicles, nitrate-free formulations are also common for their smaller aluminum-based engines. Light-duty coolants made with conventional, inorganic corrosion inhibitors must be tested and recharged periodically to maintain their potency. That's why most vehicles today are factory filled with OAT-based corrosion inhibitors to provide extended service life with lower maintenance. A global or multi-vehicle coolant formulation is intended for use in most aftermarket applications, providing an easy way for consumers to select a fluid. Most use an OAT corrosion inhibitor package, and dependent on the market, have a pale color as to not impact the installed coolant color when used as top-up. These all makes, all models products are generally focused towards broad light-duty use only. Nameplate-specific coolant formulations, on the other hand, match the OEM requirements for the engine in their vehicles, including the right ingredients for optimum performance. They come color-matched to the factory fill, making the selection process easier. OEM antifreeze coolant is a good example. Using an online tool, it's easy to find the right coolant for most light-duty vehicles. In today's complex market, using the correct engine coolant is vital in extending the life of any vehicle. This video explored the differences between light-duty and heavy-duty engine coolants, their demands, cooling needs, corrosion inhibitor packages, and universal versus nameplate-specific formulations. In the next video, we'll dig deeper into light-duty coolants and explore best practices for choosing, using, and testing them. Until then, thanks for joining us at Coolant U, where you always reach a higher degree of knowledge.